Okay, we have square root. Okay, P divided by PCR. And then we have our L squared. And then we have our pi squared. And then we multiply L over 2. And then the whole thing minus 1. Okay. So we can get rid of this, get rid of this. So therefore, E is equal to secant, right? We take out pi over 2, and then we are going to use square root P over PCR minus 1. Okay. And this is our Y max. And this equation over here, okay, I want you all to use this equation when you find Y max. Okay. Again, I repeat, use this equation. Okay, this equation, you can why this equation is used, always use this equation. Later on, I'll show you when we do examples. When you use this expression, you make less mistake. Okay, if you're going to use a very extended form, then we're going to be in a lot of trouble. Okay, right. So from here, so for eccentric loading, right, the maximum stress will be equal to P divided by A, right? This is due to the axial load. And then we have plus M max multiplied by C divided by I. Okay. Now, what term there's a term that you see down here that is C. So what do I mean by C? If you have a cross-sectional area, okay, if your cross-sectional area looks like this, right? And depending on where the buckling is, which axis, so this one, the buckling is about the ZZ axis. When this is the case over here, this is your C. And if the moment is acting in this direction, moment about Z, this is the compression part, and this is the tensile part. Okay, C is always in the compression region. Okay, not in the tensile region, the tensile half of the material, because the tensile half of the material will not fail by buckling. Only the compression side will fail, okay, will fail by buckling. Now, this is important to take note, okay? Later on, we have some problem that you have to determine what is the C value to use. It's important to take note that the C value is on the compression side and not in the tension side. Okay. Or C, again, if it's round, okay, if it's round, okay, and then this, for example, is our ZZ, okay, and again, over here, let's say now the MZ is in the opposite direction, so i.e., this is compression, and this side is tensile. Okay, I know it's radius, okay, radius don't mean anything, but you have to pick over here, this is your C. Okay, you have to pick the compression side. Okay, so now we have to compute what is our Mx. Okay, so Mx is equal to P bracket Y max plus by E, right? So this occur, the Y max is due to after deformation. The E is just the eccentric distance. Okay. So when you have this, right? When you have this, so we know that stress max now will be equal to P over A plus by P multiplied by Y max plus by E divided by I multiplied by C. Okay. Right? Multiply. So I'm going to take out, okay, I'm going to factor out P over A. So this will be equal to 1 plus by, I need to multiply by A, C, right, over I, and then I will have our Y max plus E. Okay. So we can also now consider, right, I'm going to go into the next page. Give me like another like 4 minutes. I know you guys are bored to death by deriving. Okay. So now we know that I'm going to copy this whole thing. Okay, or not, you can't remember. Even worse. Right. So over here, note, and you have seen this before, that I is equal to AR squared, second moment of area. Right? I is equal to AR squared. So now we're going to substitute that expression. So therefore, stress max will be equal to P over A, right? 1 plus by AC over AR squared, right? And then we have Y max, and then we have plus E. And now we have the expression. So we can get rid of our C's, right? We can get rid of our C. So we have this expression where we have P over A, 1 plus by C over R squared. And then Y max, okay, so we write our Y max. Our Y max, if we were to look at our expression, we have Y max is equal to E secant, right? And then this is square root P over PCR. And then this thing is on its own. Okay. Multiply by pi over 2, right? And then we are going to close another bracket. And then we have minus E, right? We have minus E. And then we have plus E. Now, over here, this is basically, if you look at our Y max expression, right? So this is our Y max. So I'll just bring it across so you know where I get the minus E plus E from. Okay, so I'm going to copy, right? So we can recall, right? So basically, I substitute this expression. I brought the E back in because if you look at this equation on its own, this is equal to E secant pi over 2. Oh, sorry, the pi over 2 is inside the, I do apologize. So this is pi over 2. and square root P over PCR, close bracket. Okay. So this is just basically square root P over PCR. And then I just put the E. Okay. So that's where this expression, this expression over here, in fact, I can get rid of this bracket over here, right? Yeah, I can get rid of that bracket over there. Okay, so this expression over here, right, is equal to this expression over here, right? And then I think I might need a big bracket over here because C over R squared is on the outside. Yeah, that's it. So from here, we can get rid of our E's, right? So finally, we have P over A, 1 plus by EC over R squared, okay? And then we can have secant bracket pi over 2 square root P over PCR, close bracket, and one bracket here, and one bracket there. Okay. So one bracket for here. In fact, why am I wasting time with that bracket over there? It's understood. Okay. So again, I want you all to use this formula to calculate your stress max. Okay. It will save you a lot of time and effort. Okay. Now, looking at this form over here, right? There's another form. Before I go on, always remember the term over here. When you calculate this term over here, always remember this, okay? This term over here is in radians. Okay, so when you calculate that on your calculator, make sure you are in the radians form. If you're not in the radians form, then later on you realize that you might be in a bit of trouble. Okay. Now, sometimes you can see the stress max in a slightly different form, and I will just derive it out for you. I will not encourage you to use it. Okay, I'm just going to derive it up for you, but I'm not a fan of it. Okay, so note that what we have over here is PCR is equal to pi squared EI over L squared. Okay, so I'm going to substitute the PCR equal to pi squared EI over L squared into the stress max. So you can also, sometimes you can also see this expression. So this is equal to P over A, right? So 1 plus by EC over R squared secant. And then you have pi over 2. And then you have square root P. And then you will have pi squared EI. And then you have L squared. Okay. So as I said, sometimes you will see this expression in this form. And then I'm going to tidy this up for you, for all of us. So this is P over A. And you have 1 plus by EC over R squared. And then you have secant. And we can cancel the pi's. Okay. And then the L squared we can remove. So you have L over 2. And then this over here is square root P over EI. Okay. And then we know that note that I is equal to AR squared. Okay. And we know that R squared is the radius of gyration. So we can also see this in this form where you have P over A 1 plus by EC over R squared secant, okay, L over 2. And then we just